So good morning. My name's Steve Butler. I'm Industry Strategy Manager with Autodesk. Thanks to my previous two speakers for putting me on the spot, and Matthew too. Great, appreciate that. Hopefully we'll not disappoint. I think you'll find my presentation a little bit of a kind of combination of what you've already seen come before, with a little bit of product in there as well. And I'm going to be talking about emerging technology trends in building design and construction. So let's start by first looking at the drivers for change, looking at where we are today, and maybe asking the question why we should change. So the two biggest global trends that our industry face arguably are globalization and sustainability or climate change. So if we start with globalization, approximately 10 billion people will be living on this planet by 2050. That's the statistic. That's an increase of 40% over the current population today in just 33 years. Our cities are going to double in size. That's the prediction. According to the World Economic Forum, that is. And they also say that around 200,000 people are moving to cities every day, and that's where we're going to see this mass expansion. So to support this growth, we're going to need to build approximately 1,000 city-dwelling buildings every day from now till then, housing approximately 500 people or more, okay? So that's a pretty significant ask, which starts to sort of set in our minds the kind of challenge we've got ahead of us. So not surprisingly, therefore, the need to increase vertical occupancy, particularly around our cities, is increasing, okay? And you can see that from some of the buildings you see before you here. Driving demands for smarter design, improved construction methodology, et cetera, et cetera. And we're starting to see some of that with buildings like Shanghai Tower, Jeddah Tower, et cetera, which have emerged over the last few years or so. And according to the Council for Tall Buildings, we've currently constructed around 144 skyscrapers above 200 meters in height. Okay, so it's pretty significant. 126 of those were super tall buildings, okay? Most of them in Asia, not surprisingly. Around 53% of those were in China. So that's where we're seeing a lot of this growth, which is areas where we're seeing also a lot of population, so no surprise. An increase of 500% since around 2006, okay? So that gives you some idea of the pace that these buildings are going up at. The challenge we have is that these buildings, although they're smarter, by and large, our infrastructure is pretty inefficient, okay? It's responsible for 40% of global energy consumption. It's responsible for around 25% of global water consumption, and then 30% of greenhouse gases. And when you combine that with 30% of construction being rework, and 20 to 50% of construction being material waste, you start to get some idea of the size of the problem. So given this challenge, given what's ahead of us and given where we are today, our industry is really in a prime position to start looking at what we do, how we do it, and trying to improve that process if we're going to fulfill the requirements and the demands of the future. The problem is that our industry really is slow to adopt new technology. I think we all would probably agree with that. Where other industries have been a lot more, certainly a lot keener, and have moved forward a lot sooner, the manufacturing industry being an obvious one. So as you can see here, I'm sure you've all seen this slide before. Anyone who's presented to management, I'm sure, has put this slide up at some point. We can see just how poorly we're performing compared to other industries. In fact, in a recent survey, we came just above hunting as an industry that invests in technology. We invest a third of what manufacturing does. Okay, so that gives you some idea of kind of the scale of the problem that we've got. And it's not surprising, right? If you look at our construction sites today, they don't look a lot different to they did 50 or so years ago. On the left here is a site from 1950, and on the right, construction site from just last year. And, according to the World Economic Forum, the challenges, the reason for this low productivity are things like fragmentation and the lack of collaboration in our industry. And we already heard that from the presenters previously. So leading to poor quality information exchange, disconnected processes, We frequently hear about people not sharing information, not sharing models. Alain spoke about this being, companies' IP, and they need to get beyond that. They need to start thinking more about where that IP is and it's not in the model, and start to exchange and collaborate better. We're also, the World Economic Forum also tell us that we have an inability to attract and to develop talent. And we all know there's a talent shortage, right? It's not sexy to go and work on a construction site. And our workforce is aging. And as our workforce ages, so with it, as it retires, is that knowledge that's in their head. So we need to find new ways to capture that knowledge and disseminate it. And then lastly, the World Economic Forum tell us that there's insufficient knowledge transfer. We don't take enough from what we've done on previous projects, learn from it, and then use that going forward. And this is speaking to more of the sort of, AI topics that we'll touch on a little bit later. So that's what we really need to do to try and begin to transform our industry. And it's not surprising that we are where we are. This is an example from Beck. This is, not too dissimilar to your processes, I'm sure. Typical project, typical phases, decision-making. It's pretty familiar, and it's super complex. But there are better ways to tackle this problem, and we've already spoke about some of them. Last year, McKinsey Institute came out with a report that had 7 strategies for improving productivity. These are those. They range from reshaping regulations, contractual framework. We all know that the challenges around that. Some of our contractual frameworks are a little archaic. Procurement, supply chain, earlier engagement, speaks to collaboration. But if you look at these, many of them are underpinned by BIM and what you can do with BIM processes. They're certainly underpinned by digitalization and often by the cloud and the benefits that cloud can offer to these processes. So what we're going to look at today are the technology trends of these 7 strategies. And they look a little bit like this. So high definition surveying, Steve touched on this a little bit. I just spoke about the cloud, infinite computing, the fact that it's now ubiquitous. You can get data anywhere, everywhere, on any kind of device. Collaboration, machine learning. We'll talk a little bit about IoT and industrialization of construction. So starting with the process of BIM itself, when we connect traditional desktop BIM processes with the cloud and the power that offers, we at Autodesk call that connective BIM. So essentially what you're doing is you're taking what you're doing in isolation and you're putting it in the cloud, you're using it to process, or you're using it to share and to collaborate. So that's what we refer to as connective BIM. And it really allows us then to start to break down some of the barriers between exchanging information and engaging the supply chain, for example, earlier in the process, helping to inform design decisions. So let's start with the typical project lifecycle and some of its activities, and look at where the technology fits into the design, build, and operate sort of process. This will sort of highlight some of the activities that we typically perform within the industry. And we're going to start with design and looking at some of those processes, some of the emerging technologies and processes in that sector. So the first one is around laser scanning. Steve touched on this a little bit. This is becoming huge. In fact, BD and C estimate that the 3D laser scanning business is going to grow by around 17% annually to reach about $5 billion by 2020. That gives you some idea of how invested people are in this. It's being used in a couple of different ways. As Steve said, it's a great way to capture existing conditions. And when I talk to customers, they use this technology even when models exist, even when documentation exists to already support an as-built condition, because they trust it, because it's more accurate, and because they can quickly do things like this. They can take the point cloud, bring it into Revit, they can start modeling with it. There's even tools that will highlight point clouds and say, you're a pipe, add it to this service, and really accelerate the modeling process. So it's becoming really, really ubiquitous. And the main reason for that is it's minimizing the risk, obviously, in the field. The accuracy, there's no measuring, and that stuff still goes on, as we know. It's improving all sorts of processes of productivity and efficiency. So this is really beginning to take off, and I'll show you another example of this used in the construction phase a little bit later on. So this is where a lot of projects start. If we look at sort of the project process, if it's a renovation, obviously this is where it starts, and some of you already said that you're doing this. The next part of that phase is really being able to take that model and do something with it that makes sense. So not just 3D coordination modeling. Thankfully, when we talk to engineering companies now, they're starting to get beyond that. Well, we want it for 3D, we want it for coordination. They want to actually interrogate that model and do something with it. This is Insight 360 from Autodesk. It's been historically aimed very much at sort of the architect, I guess the building physics engineer, MEP engineers to some extent, and in the future, you'll see more from us in that direction going towards the MEP design space. What's interesting about this particular tool is you can take that point cloud converted model, or you can take the architectural model. Without any modification, you can send that to the cloud, and using the DO2 engine or the Energy Plus engine, you can start doing things like heat and cooling loads, and really analyzing that building to get some really good results really early in the conceptual design stage. Without a lot of data, you don't actually need a lot of information to start getting these types of results. And this energy cost range allows you to analyze what you're getting back. So what's different about what we offer from Autodesk to some of our competitors is it's not a black box. Typically what happens with energy analysis and these types of tools is you send, you do some analysis on a model, you get the results, and you kind of live with whatever you get back, or you redo it. What we're doing here is we're sending it to the cloud. We're using the power of the cloud to mass process that and bring back hundreds and hundreds of different options. And then we're presenting you those options and allowing you to make decisions, such as changing the glazing, such as changing the orientation of the building, as you see here. And then you can start to see what those subtle changes will do. What effect will that have on the cost of this building, on the performance of this building? So you can start to iterate or optioneer over many, many different scenarios, which you couldn't do before. And the power of the cloud is essentially saying, look, you don't have a lot of time. That really probably hasn't changed, but we could help you out by doing this faster, quicker, using the cloud to do that for you, doing it overnight or just doing it in parallel to whatever else you're doing at the time. So this is where the project moves next. Into then sort of a visualization sort of stage. And visualization isn't new. We've all been doing this for years. What is new is some of the hardware technology that enables you to take that model, visualize it, and then start to do things with it. So using some of the hardware that exists today, this is Revit Live, which is in the AC collection. You can now start to take this model, sit with your client, immerse them in the building, and start to question, what it is they want from this new space. And you can start adjusting the lighting levels. You can start looking at natural versus artificial lighting. What kind of strategies are going to best work. This feeds into the wellness of individuals within that space. There's a plethora of things that you can do by just getting inside that building really, really early on and starting to work with the client or starting to work with the extended design team. This is using technology that you've probably used already, like our solar lighting, solar analysis and lighting analysis tools in the cloud. In the back end of this is that same engine. So you're able to expose that technology or get access to that technology from inside this type of technology. So you can start looking at different times of the day. You can start looking at different locations, et cetera, et cetera. It really starts to help you to build a different sort of relationship with those you're working with and really inform better the decisions that you need to make at that time in the project. So moving into detailed design, whoops. Apparently there's music. Okay. Well, hopefully you can hear me over that. Moving into detailed design. And this is one of the fastest growing trends that we're seeing amongst design engineers around the world, which is computational or generative design. And this is computational design or generative design is becoming the fastest growing sort of trend amongst engineers, because what it allows you to do is start to build tools to really interact with the model and start to interrogate the model, and not just automate tasks, not just to make it easier to lay things out or do repetitive things more quickly, but to actually go in and start analyzing the model in very different ways. Here you see it creating a structural frame, putting in the structural detailing, and then in this case here laying out the beginnings of a bridge. And what we can do is start doing what if-else type scenarios. And as you change the script on the left-hand side, the model automatically updates. And you don't need to be an expert in programming to do this. You saw a little bit of this from Alan. How many of you have used Dynamo or seen Dynamo? And there's quite a few of you. Okay, excellent. So that's kind of the first stage in the process, really, which is starting to automate design using tools like this to keep everything in sync. Okay, and what that allows you to do is to generate massive amounts of options, again, using the power of the cloud. So design alternatives that you wouldn't have been able to arrive at, in the old-fashioned days, right? But then what we do is we take that and we move that to the cloud, and we use the power of the cloud to generate multiple options. So this is Project Fractal from Autodesk. This is something you can try out if you want. That will allow you to build a smarter, more intelligent sort of approach to your design. So this starts to take you from sort of basic automation to actually doing optioneering. So as you see at the top of the screen there, you can start adding rules that say, I want to look at my building from this perspective. So, the heating load, the cooling load, what's the glass ratio to wall percentage, and start looking at these options and put these in front of the client again and have a different kind of conversation. So you can start to really optioneer and engage in a way that you haven't done before. And then beyond that is tools that can really start to influence the decision in other ways. This is our new building in Toronto, the Autodesk building in Toronto, and we use this same technology to basically go in and start looking at different options for laying out the space based on things like, natural lighting entering the building, adjacency preferences. Maybe you want to be close to the kitchen for some reason. Maybe if this was a hospital, you'd want the theatre, the operating theatre, to be near waste, so people don't have to travel quite so far, which is a common problem in those sorts of places. All those kinds of options can be put into a machine like this and basically optioneered, and it can come back with all sorts of decisions that you can then start to iterate over and make more informed decisions. So exterior view preferences, daylighting, all this kind of thing. If you're going to have certain activities over here, how will that impact activities somewhere else? And beyond this comes machine learning. So the next phase of this is really starting to just pump in certain parameters that will then come up with your ideal scenario, which you can then go in and further start iterating over. So this is sort of the first phase of that. And if you're interested in this type of technology, you can go to our Autodesk research website, and there's loads of examples of this kind of thing, including some machine learning examples. Which leads us to a basic version of that, really. So this is, again, sort of, I guess, computational design meets, some very basic machine learning. This is a company called Building SP. And what they're doing is they're laying out, in this case, conduits, but it could be anything, pipework, ductwork, within the model using a basic set of rules. You tell it where you want to start and where you want to end, and it then routes this, in this case, services around the building, and it avoids clashes with everything else, so beams, structure, architecture, etc. And you can save those preferences and rerun them. So when the architect changes the ceiling arrangement 24 times a day, you can just rerun this script, and it will find where the changes are, it will reroute your services, and it will avoid the clashes. Okay. What's really interesting about this technology is that it also works with point clouds. So it's smart enough to be able to move around sort of the point cloud model as well. This is still in its basic form, and it's actually, I think, a beta release at the moment. But you can start to see how this becomes really helpful when you apply certain rules. So if you can say things like, make sure we're 50 mil off the bottom of the deck, or if you can say, I need 100 mil for access to all inline equipment, then that kind of ability will allow you to actually route with some degree of confidence, and at the end of the day say, look, I think this service is going to fit. Now at a design level, that's probably sufficient, right, for design intent, but it saves you so much time. You can go in and start really analyzing the model to make sure it's absolutely accurate. So there's definitely a place for this kind of thing. And it's got a lot of interested parties in the US. So that's from a design perspective. We move into the sort of emerging technology around construction. What we've been doing with the Revit platform over the last sort of I guess, 3 or 4 years, is trying to support the ability to go from design to detailing, as we call it, or LOD 100, 200 to LOD 400, all on the same platform, as you see here from a structural perspective. So this is rebar. You take the design intent model, you're able to segment it out. It will do reinforcement. It produces automatic shop drawings, aids reinforcement, puts in openings and adjusts rebar accordingly. There's a lot of logic built into this. So you're able to pass your design intent model to the trade contractor and have them actually move that forward rather than redraw everything or remodel everything. So you're not throwing things over the fence anymore. Extending this ability to collaborate, you're now working on a single model authoring platform, which of course has a lot of logic behind it to enable you to then push this downstream to other activities or in parallel to activities like estimating, procurement, that kind of thing. And this is an example of that. This is a firm in Mexico who are literally taking the Revit model, converting it to the detail that you saw, and then pushing this out to manufacturing. They used a middleware to do things like labeling and that kind of thing, but you basically get the idea. Well, at least it's different music. Cowboy music gives you some idea where these videos come from. I'm saying nothing. Yeah, let's go here. Apologies for that. So yeah, doing it with concrete. Again, segmenting up. This is actually an example from a company called TBI Vorbij in the Netherlands, producing shop drawings, and then using the model to actually drive manufacturing in the shop. What's pretty interesting about this particular company is all those pores are calculated from the model. So it's all driven. The automation is all driven from that model. And when I first went to the company, there were literally, I don't know how many people on the shop floor doing different tasks. That number has now significantly dropped through the use of this type of automation as we start to see robotics coming into play and intelligence being driven from the model. And of course, that's being also used for MEP, for modular prefab. Steve touched a little bit on this. For things like pods, it's been going on with pods for ages. We've had modular MEP in the UK for, 15 years or so, maybe more. It's just not really evolved, not really gone anywhere. There's no real standards around it, and it's tended to sort of stagnate into what it is. And there's only really a few really doing it. But it's picking up a lot in Australia. It's picking up hugely in the US. And this is in Europe, as I say. This is VBI Vorbij using the model to kind of do, in this case, panelization. So there's definitely a trend towards being able to connect the design model to detailing and the detailing model downstream to fabrication. And this extends into the MEP world. So what we've been doing with MEP is, again, allowing you to take that design intent model, convert it, send it through our CAM software straight to the shop floor for manufacturing, or send it from the model straight out to our estimating software, SMEP, to be able to do pricing, procurement, et cetera, et cetera. This is an example from a company called Hill Group in the US, who are also using it to drive things like pipe cutting. We've also got partners that export directly from the model to bend tube, bend pipe for conduit. In America, they bend a lot of conduit. So there's a lot of manufacturing being driven from these processes. And in fact, the way we communicate from the Revit model to our CAM software is actually being brought into our Inventor software as well. So you'll be able to use TrueNest as a plugin inside of Inventor, and you'll be able to communicate between Revit and Inventor if that's your preference. So there's lots of different ways that we're starting to bring our technology together as we see the industry converging from a construction and manufacturing point of view. What's interesting about this is, if you now within Revit, as soon as you place a duct, you know exactly how long it's going to take to install, you know exactly what types of connectors it's got, you know how much it's going to cost. From that, you can drive delivery, just-in-time delivery. You can also, it will list every nut, bolt, screw in the background. So that's the kind of information you can now get from the Revit model. And this is an example of extending that still further downstream into the field. This is a company called Andy Egan in the US, who basically were doing a lot of the traditional things that many of you as contractors would do, which is to, do a lot of manual work, spool diagram, etc., send it to the shop, and then they sort of basically do some prefab and then push it out to the site. The problem was they had so many projects going on at the time, they had no way of tracking materials. They had no way of knowing, is this material in the shop? Is it on the back of a truck? Has it been installed? Et cetera, et cetera. So they adopted our BIM 360 platform. Using that with Revit, they were able to use Field to be able to commission things, to be able to snag things, to be able to communicate back and forth with the office. And for them, the biggest thing, aside from being able to track where materials were, was the fact that in the field, often people are working off old revisions of drawings, old information. So this was a way of keeping everybody on the same current version of information. And also, as soon as a change needed to happen, everybody was able to communicate using the same technology, see what the problem was, and come to a conclusion quickly in a timely manner. And we're also seeing partners adopt our Forge platform. If you're not aware, Forge is the Autodesk cloud sort of platform. And a lot of our partners are moving to that, essentially to take advantage of the processing power we talked about in the previous examples. This is a company from the US, a company called GTP, and what you see here is them taking a Revit model. In this case, it's a pipework model. And then they instantly, in the cloud, so what you need to remember is you're outside of Revit here, and they've taken the Revit model via BIM 360, they put it in the Forge viewer, and they're then working iteratively inside the viewer. So this doesn't have to be a Revit expert. This doesn't need to be somebody in the shop who needs to know Revit. They just need to have access to it and Forge. They break the project up by grid, so they instantly overlay the grid. They then break the project model down by grid, so you can start to say, within this section, I'm going to start to generate this number of spools. So you can then create these spools. You can auto dimension these spools, as you'll see here. And then you can start to process orders. So you can start to then get quotes, place orders, monitor those through the process. Has the material arrived into the shop? You know, has it been manufactured? Has it been installed? And you can also use it to drive fabrication. In this case, the Tiger Stop to cut pipe. So it pushes the information from the model straight out to the Tiger Stop cutter. As soon as that piece of pipe is cut, its status is updated in the model, and the model is color-coded to tell you just at what state that model's in. Is it in the shop? Is it finished? Is it been installed? Has it been commissioned? And of course, at that point, you can start to invoice. And this is a Kanban board that basically allows the people to move, the process around very quickly, very easily, providing everybody on the project visibility into where the project is at that time. Once work begins on site, we're starting to see a lot of sort of augmented reality tools. This is a QA, QC tool. Steve touched on this a little bit. It's pretty impressive. What it enables you to do is, obviously overlay the model with the real world. And you can do that at any phase in the project. So you're then able to say, well, what's it going to look like when the conduit comes in? What's it going to look like when the ductwork gets in? This should be in and it's not. You can say, well, this is installed, but it's actually not installed where it should have been installed. And at that point, you can start to annotate, annotate the model and start to provide feedback to whoever you need to in the office. So you place a grid, you can then put annotation in, put dimensions, notes, etc. And it's a pretty dynamic way of being able to interact with a client on site or interact with other stakeholders on the site. And to really try and assess progress, I guess, in terms of percentage install. In fact, tools like this, they're starting to really find their way now into the construction site because everybody seems to have a tablet. That's certainly increased. I don't know what that's like in the UK, but certainly in the US, we're seeing a lot more tablets being used in the field. And according to JB Knowledge, saving 5 minutes per worker per day is equivalent to 1% of project margin. So these types of savings are really starting to pay off. And it's not just that. We'll show you some other examples that can improve efficiency in the field. We're seeing a lot of companies starting to play around with things like HoloLens and AR technology. This is Gil Bain in the US working with us and MIT as it happens. But we're seeing other companies as well, Gensler, Egan, companies like that, starting to see just how they could use this type of technology to in the field. And you saw the example from Martin Brothers earlier, which was an interesting one. This is actually in the field, trying to identify where there were going to be potential issues prior to installation. And in this project, which was a prototype at the time, they managed to save $5,000 by identifying a particular issue in the length of steels. So they definitely saw value. I think the challenge that we see at the moment in industry with this type of thing going mainstream is the durability of the hardware, and the extent that the range of the hardware. At the moment, there are certain limitations there. I think software-wise, the technology is pretty much there. But there's a lot of this starting to emerge. Is anybody actually doing anything with HoloLens at the moment? No? Okay. It's a pretty interesting technology. There's a company right here in London called Kazenda, and they're doing some really interesting stuff in the construction space. If you're interested, I can put you in touch with them. Again, augmented reality. This is what's particularly nice about this is it's allowing one or more person to interact with the model, obviously before it's installed. And this sort of scenario allows you to say, well, look, this is how we're going to install it. This is how we're going to suspend it. These are obviously the challenges that we're going to face when you can walk to a Battersea power station and say, this is what the pump skids are going to look like, and this is where they're going to go. And you can start interacting with the people that are going to install it. This sort of technology starts to pay for itself. And there's a lot of interest in this type of thing, being able to sort of overcome the need to wait till you get to site, this culture of RFIs, etc. You can just interact much earlier in the project phase. And you don't need a lot of technology. So this is JE Dunn using the Forge platform. You may have seen examples of them connecting their software to back-end ERP systems. This is them connecting their workforce in the field. So here they're using an iPhone or smartphone with a $10 cardboard viewer, and basically providing everybody with the ability to go in and use VR as a tool to solve problems. So in this scenario, I'll just play it again. What you see is this guy here has no clue how to overcome this problem. A real challenge for him. But he knows that somebody else in the field does have that knowledge. So he sends the model to that person. They're able to then view that and immerse themselves in that space and help solve the problem. And so, of course, there's lots of different ways that this technology could be used to disseminate other types of knowledge. I mentioned previously that our workforce is aging, so how do we get all that information that's in their heads out to the younger workforce? Well, this is just one way of doing it. I've heard of companies putting older people on sort of phones or using technology like this back in the office, so pulling them off the site into the office and being able to service many different crews out in the field. The other thing with technology that's really interesting, particularly from a model perspective, is how it's driving robotics. This is the world's first drilling robot. It was used on a project in the Nordics by Skanska, and the company's called Enlink. And what's interesting is it's very, very similar to the robotic total station layout. So today, you can take the model, you can take the points within the model, the hanger layout, you can push that straight out to the robotic total station, and obviously it does what it does. This is the exact same process. This is using a Revit model to drive the layout that this model this robot is performing. And this is about 8 times faster than the more traditional processes. So again, going back to that sort of trying to recover the value in the field, trying to sort of maximize your margin, this is just one of the ways in which we can do that using the model to drive robotics. And wearables are becoming huge. So, probably the fastest growing area I would say in construction is around wearables, things that can sense, certain types of contaminations. Is there a loud noise in your locality? In this example, as you can see, this woman's wearing a vest. She's walked into an area of the construction site that is hazardous. It's instantly alerted her to that fact. Through the lights, it's also vibrating. And then the foreman, who has access to the technology, gets notified that somebody or some people have walked into an area of the construction site that's potentially dangerous, and he can go there and address the problem. And we're seeing other sorts of technology around people falling, built into things like hard hats and suits, which is really beginning to drive a lot of improved safety within the construction site. In fact, I think the construction business is probably one of the most lethal businesses out there compared to the medical business. So we're in a pretty bad way. Technology like this, is really helping to improve things in the field. Steve touched a little bit on this, and this goes back to sort of reality capture, which I spoke about at the beginning, really. This is a couple of different ways in which we can use reality capture to measure what's been installed, percentage complete. This has just come out, actually. This is a fairly new device, and it's real. You can actually go and buy this. And this robot basically does a scan that will then enable you to determine earned value. So you can start looking at percentage complete for your mechanical services, your electrical services, plumbing, etc., and start to get that value straight away at the end of the project. So at the end of the day, you send these bots out, they do the analysis, and in the morning you know exactly where you are. This saves you walking around the project site in the rain with a pencil and a bit of paper, estimating that you're about 60% complete on something, when in fact you're nowhere near that. So this sort of is getting, certainly in the US, a huge push because of the fact that it can more accurately calculate those kinds of things. So finally, let's look at the operations space. So one thing I find particularly interesting is that a lot of companies I go and talk to, and I would expect this from sort of the trade contractor who, at the end of the project, knows more about the building probably than anybody in terms of what's been installed, and of course then sees an opportunity to look at maybe moving into facilities, management, maintenance, that kind of thing. But I'm also seeing a lot of design firms, consultants, interested in moving into this space. And there's some interesting technology emerging. So today, we have some technology called Building Ops, which is available on your iPhone. It's really more about sort of deploying a team to solve particular issues, tracking those issues, and you can drive that through a plugin in the Revit model. So you can say this piece of equipment that has links to this particular manufacturer's PDF around installation, maintenance, et cetera, or even to this schedule. You can send that information to your workforce, and you can start to set tickets up and track their progress. They can make notes, they can get into the model, inspect it, get the information they need to try and solve these problems whilst they're in the field. And then they can update the status of it so it gets straight back to the office. They know everything's okay, or they know that they needed to respond accordingly. So that's kind of a nice way of being able to use the model to track things. And we're seeing other examples of that, as well as things like AR. You've probably all seen Daiquiri. Has everybody seen Daiquiri? No? Okay. So Daiquiri is smart helmet. It does AR, basically built into this visor on the front of the helmet. You can go out in the field and use this technology to essentially identify key pieces of equipment. And it's using this sort of, I guess, some sort of level of machine learning to basically say that's a pump. We know what pump it is. We know what part of the building it is. And it can start serving up information to help you to maintain it. So this is obviously, again, back out in the field using a device to be able to interact with the physical things, to be able to say, okay, here's a problem. How do I fix it? So this is, I think this still has to come to market in terms of mainstream. I think there are cases of it in beta, but it's an interesting piece of technology. As Autodesk, we've been playing around with IoT and sensors and facilities maintenance as well. So this is a project called Dasher 360. You can actually try this. If you go to a browser and type in dasher360.com, you can get to this. And essentially what it does is it takes you to our model of the Autodesk building in Toronto, and we've hooked up sensors to it, so you can start to see some of the data in that building. Now, obviously, for the purpose of this exercise, it's recorded data, but we actually have this live at our San Francisco office where you can go and start playing around and saying, this is the humidity level in this type of building, or this is lighting levels in this building, using this type of technology. And so what it's doing is, you see there, it's using our Forge platform, our Forge model viewer. You can interrogate each one of those green items is a sensor. And as you click on it, you can start to see the information that it's recording. You can then drill down into a particular area of the building. You can see things like heat patterns. You can start to then go further in the first-person view through the model to a particular area of concern and turn off anything that isn't of interest to you, and then just drill down to the one thing you need to focus on. And that helps people that are working off-site to be able to maintain a facility. The other area of interest for us here is being able to measure how a building actually performs. There's a lot of interest in being able to see, is this building actually doing what we said it would do? You know, we've done all this energy analysis, we've got LEED ratings, whatever, but you know, it depends how it's installed, it depends how it's occupied, used. We all know that, right? And we know that 9 times out of 10, that building is never going to perform the way that we've designed it to perform. So now we can start to really monitor that. And that's technology like this that's enabling us to do it. And we're working with a couple of companies to see how, you know, how we can push this technology further into the field using IoT and the cloud. But that's kind of a research project, so that, again, you can try that. But that's areas we're focusing on at the moment in terms of using the Revit model. One real-world example is this. This is from a company called EMSD in Hong Kong. They're part of the Hong Kong Healthcare Association. And basically, they linked the Revit model with their BMS system with their sensors. And they're able to go in using an iPad, drill down through the model in a particular area where there's, you know, some concern. They can start to identify particular systems and then zone into a particular valve or, you know, damper or whatever it is that's causing the problem. In this particular example, it's I think it's an actuator of an air handling unit here. So we're able to see that it's connected to this system, and on this system are all these other elements. And of course, we can then use the BMS to say, historically, this hasn't performed very well, that's always failed, et cetera, et cetera. So they've got a way of connecting information to people to help solve problems. Once they've identified the problem, they've used Autodesk Fusion 360 to model how to solve that problem. So they have a whole O&M sort of kit available to their people through this technology that tells them, go in, find this piece, take these screws out, do this, fix the problem. So it's a way of connecting different technologies, connecting people with the cloud, and information to be able to support better decision making. So those are the sorts of trends that we're seeing at Autodesk, and those are some of the things that we're working on, really all associated with, you know, connected BIM, connecting the process from design through detailing to construction and maintenance, using things like the cloud and the power of Forge. Okay, so I wanted to share with you. Thank you.
Thank you, Steve.